This is a video to show you how to do problem 9.43. A manufacturer is claiming that the cans of soda do not have more than 30 calories. So the manufacturers say, no, they aren't more than 30 calories. However, we're going to try to show this is false. We believe they are more than 30 calories. So if we're going to try to show it's false, we're going to try to say the average is above 30 calories. And so we're going to use a null hypothesis of the mean is less than or equal to 30 calories. We're going to have some sample information. In the sample, it tells us that we're going to investigate a random sample of 64 cans. And out of that sample, it has an average of 32 calories, so that makes it X bar. And because it was from the random sample, the standard deviation is S for 3 calories. We're going to use the sample to indicate if we can confirm that the manufacturer is wrong. It also says we're going to have 5% level of significance. So our second step is to figure out which type of distribution we're going to use, and here we're going to use T. We have a big enough sample size, but only S is known, not sigma. Our third step will create the test statistic, and it's going to be t-test because we are using T. And when we plug in 32 minus 30 over 3 over square root of 64, we're going to get, as our t-test, we're going to get 5.33. Notice that this was 30 because it has to match with what came out of the hypothesis. Now the book says we should use the p-value method, but you can't find a precise p-value using T, so I'm going to use a critical value method. And what that means is I'm going to figure out what's my rejection region. So my rejection region is going to be on the right, and the reason it's on the right is because of the greater than sign in the alternative hypothesis. So if it's one tail only, what we're going to do is make the whole tail the level of significance, and that means I need to use my t-table, look at a 5% column, and I'm going to use degrees of freedom of 64 minus 1, or use 63 degrees of freedom. So when I look at 63 degrees of freedom, my critical value is going to be 1.669, and critical value is always the beginning of the rejection region, because it's the standard of proof that I need to make my decision. Now we can see here that our t-test was huge. 5.33 is way into the rejection region. So with such a huge value, we probably wouldn't have even needed to use the table if we realized that critical values are generally, with a large sample, they're never going to be above around a 3. It's only when you get into small samples that it becomes larger numbers. So we're well into the rejection region. So we're going to have a conclusion that says reject the null hypothesis at 5%. which then we want to decide what that means. That means we are correct, average calories are above 30, and that also means in our case that the manufacturer was wrong. And this is at 5% significance, which, remember, that's our standard of proof, or the probability that we have made an incorrect assessment if the null hypothesis had been true.